as child nodes, 30 and 45 as the child nodes of 40. So this is how easily I can create a binary tree using Python. Hello everyone, welcome to Intellipaat's YouTube channel. This is the part 4 of the Python data structure series in which we are going to discuss nonlinear data structures, trees in Python. So let's take a look at the agenda for this session. First of all, we're going to start with the basic introduction to trees in Python. Moving further, we will discuss various types of trees and their traversal methods. After discussing how to implement them using Python, we will perform various operations. And finally, to sum up this session, we are going to show you the implementation of binary trees using a Python library. I hope the agenda is clear to you guys. So without any further ado, let's begin. Before we begin, don't forget to subscribe and press the bell icon to get latest updates from Intellipaat. What are trees in data structures? Trees data structure is a hierarchical data structure in which each node is connected through edges. The starting node of the tree is known as the root node and the subsequent nodes are called child nodes. For each node that will have a child node in the tree, it will be called as a parent node, and the child nodes are called as left or right child nodes. The last node in the tree is known as leaf. For example, in the diagram over here, 50 is the root node, and after that, if you take 40 as an example, it is a parent node to 30 and 45, where the left child is 30 and right child is 45. And then again, the leaf nodes are 30 and 45. Using a tree over other linear data structures like stacks, queues, and arrays, it actually comes out of necessity to reduce the time complexity that is faced in linear data structures. Trees can reduce the computational time to a very efficient extent. So let's go ahead and take a look at a few of the types of trees in data structures. There are several types of tree available to us, so we're going to take a look at a few of them, namely binary tree, binary search tree, and AVL tree. So in a binary tree, there can be at most 2 child nodes for each parent node, and the parent node will point towards the left-right child nodes, along with the data information that it will have. For the binary search tree, each node can have a maximum of 2 child nodes and have the characteristics that help in maintaining the sorted list of numbers. This happens because the left subtree and the right subtree will have values lower than the root node and higher than the root node respectively. Searching a node in a binary search tree enhances the time complexity. Therefore, it is one of the most important types of tree in data structure. Next up, we have the AVL tree. In AVL tree, there is an additional parameter called balance factor in addition to the normal binary search tree. The values for the balance factor can be either 1, 0 or -1. The balance factor of the tree is nothing but the difference between the height of the left subtree and that of the right subtree of the particular node. The height in this matter can be defined as the height of the root node or the depth of the deepest node. So if you take a look at the example over here, in this particular example, if we take a look at 50 over here, the height will be 2 and the depth will be 0. And when we go on downwards, the height will decrease and the depth will increase. For the leaf nodes, the depth will be 2 and the height will be 0. So that is how we calculate the balance factor, in which the balance factor is nothing but the difference between the height of the left subtree and that of the right subtree of the particular node. Now coming back to tree traversal, there are mainly 3 types of tree traversal that we're going to talk about, which is pre-ordered traversal, post-ordered traversal, and in-order traversal. In the pre-ordered traversal of nodes, you will first visit the root node, and after this you will visit the left subtree nodes, and finally you will visit the right subtree nodes in the tree. We are just going to take a look at the examples over here. For this particular tree that we have, so the pre-ordered traversal will start from 50, where we are basically visiting the root node first, and after this we are going to visit the left subtree nodes, which is 40, then we go to 30, and then we go to 45, and last we have to visit the right subtree nodes, which is 60 over here. In the post-order traversal, you will visit the left subtree nodes first, and then visit the right subtree nodes, and finally visit the root node in the end. As you can look in the example over here, the post-order traversal will start from the left subtree nodes, which is 30, and you go to 45, then you go to 40, then you will visit the right subtree nodes, which is 60, and last but not least, you will visit the root node, which is 50. Now coming back to in-order traversal, in the in-order traversal of trees, you will first visit all the nodes in the left subtree. After this, you will visit the root node, and finally you will visit the right subtree nodes in the tree. So the in-order traversal will start from the left subtree, which is 30, and then you go to 40, then you go to 45, then you go to 50, which is the root node, and last but not least, you will visit the right subtree nodes, which is 60. So that is all about the tree traversals, guys. And let's move on to the operations, where we're going to show you how you can implement trees data structure in Python, or basically how you can implement the binary and binary search tree in Python. So starting from the beginning, First of all, we have to understand how we are going to implement the binary tree using Python. So if you have come across the previous parts of this data structure series, you must have come across the linked list, and there you must have learned about the classes and objects, how we were using for nodes and how we were using the linked list over there. If you don't have any prior knowledge of classes and objects, it's advisable you should check out the tutorials we have on our channel to learn about classes and objects, and then after that it will be easier for you to understand these concepts. Now coming back to our session, we have created class called node over here, and we have three parameters basically, which is the data, that is going to be the information stored in that particular node. After that, there is the right pointer and the left pointer. These are basically going to point towards the left and right child nodes of the parent or the root node. Now, since we have created our class over here, we need to add a few values or add nodes into this tree. Now, to insert the elements, we are again creating a function over here. So we have a function over here which we are using to insert the values inside our tree. So we have a few conditional statements over here which we are going to check if the value or the data is less than root node or not. If we are also checking if the value of the data is greater than the root node or not, and accordingly if it is not none, we are basically creating a node in the left subtree or the right subtree over here. And if we do not have a root node, it is basically going to create a root node for us as well. Now let's just run this. So this is the function that we are going to use to insert the value inside the tree. Moving on, before we can put it to our test, if we can actually add the values or not, let's just talk about the tree traversal which we have just discussed. So it is basically the in-order traversal, the pre-order traversal, and the post-order traversal, in which we are basically going to visit the left subtree, right subtree, and the root node accordingly. For in-order traversal, we are basically visiting the nodes in this left subtree first, and after that we are going to visit the nodes in the right subtree. Similarly, we are doing this for pre-order traversal also. We are visiting the root node first. After that we are going to visit the left subtree, and then moving further we will visit the right subtree. And for post-order traversal, again we are doing the same thing, and we are using recursion for this so that we are able to reach all the values inside the tree. Now this basically what we have is a function or a few functions which we are going to use to display the values, or in order, in pre-order, or in post-order traversal. Now let's just run this again quickly. Now to look at the final look at our binary tree, what we have is the class node, which I already told you, which will have three parameters: data, the right pointer, and the left pointer. After this we have created a function to add the values, and it will check whether the data is less than the root node or if it is greater than the root node, and accordingly it will add the values or the nodes inside the tree. Then we have the traversals: in order, pre-order, and post-order traversals. Now comes the tricky part here, or the fun part you can actually call it. So we are creating a root node which is 50, and then we are adding a bunch of nodes like 40, 60, 30, and 45. So using the in order traversal, let's just see what the output is. So for the in order traversal, we are getting the values as 30, 40, 45, 50, and 60. So if we go back to our presentation and check the in-order traversal, it is 30, 40, 45, 50, and 60. So we're getting the same values using the in-order traversal again. Then we can do this for the post-order traversal again. So these values are 30, 45, 40, 60, and 50. So the root node is basically going to come at the end of our output over here because we are using post-order. And if we check the post-order traversal, we're getting the same value. Now after this, we can check for pre-order traversal again. So we are getting the root node first, and if we check in the output over here, in the pre-order traversal, we go to the root node first, then the left subtree and the right subtree. So these are the values that we are getting. So right now we have implemented a very basic binary tree using Python, and we have used basically classes and objects in this, and we have used a bunch of recursion method where we are using it to iterate. Instead of iterations, we are using recursion over here to reach each and entire nodes in the trees. Alright, so after this, let's just talk about how we can search a node inside a binary tree. Now this is very simple, guys. It's like basically checking one value and iterating it over the entire tree, on the left subtree, on the right subtree, and we are basically checking if the value is there or not. And if we have those values, we are basically returning true, and if we don't have those values, we are printing false. So this is a very simple example of how we can search the nodes in a binary tree. We have a function over here. If the data is equal to value, we return true. Now we check if the value is less than that data and if the value is greater than data. So if it is greater, we are going to check it in the right subtree, and if it is less than the data, then we are going to check it for the left subtree. Moving further, these are two approaches where we can find the minimum and the maximum from the tree using recursive method over here, which we have, and then again we can use the iterative method also.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by E&ICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
To iterate over the entire tree and find out the maximum values. So we're going to use these functions, the searching function and the minimum and maximum function also, in just a while. Before that, I wanted to talk about how we delete nodes in the tree. Now deleting a node is a little bit trickier because we may have three conditions over here. Let's say if we want to delete a node which is the last node, we can just replace that value and point it null, the previous one. But if we have to delete the node with one child node, what we have to do is we have to replace the node with the child node, and we have to remove the child node from its original position. And then again, if we have two child nodes, if we want to delete a node which has two child nodes, what we have to do is we have to get the in order successor, or basically the minimum value of the node, and then we have to replace the node with the minimum of the subtree, and this removes the in order successor from its position. Now to understand this, let's say this is our function over here. First of all, we are checking the value if it is greater than or less than, so that we know if we have to search it in the left subtree or the right subtree. Now if we find that value, particular value, and this is the last node, basically we will just use recursion and delete that particular node for the right subtree and the left subtree. But if let's say if it has one child node, what we have to do is we are basically having this temporary variable which is pointing to self.right, and then we point it towards none and return the temporary variable. So what we have done over here is we have replaced the node with the child node, and we have removed the child node from its original position. Now we have to do this for both of them, the left subtree and the right subtree. Now let's say we have to delete a node which has two child nodes. So what we have to do is we have to get the minimum value of that particular node, and after that, and then we have to replace the node with the minimum of the subtree, which we are doing over here, and we have to replace the value with the minimum, and after this we are going to remove this successor, or basically we are removing the minimum value from its position. So this is how we delete nodes inside a binary tree. Now let's again take a look at this. We have class node over here which is going to create our tree. Then we have the addition function over here which is going to add the nodes. We have in order traversal, pre-order traversal, post-order traversal, and then we have the search function. After this we have the getMax function. Then we have the delete function, inside which we have also created a minimum value function, because this is what we are going to get the minimum value for us while deleting the node which has two child nodes. And we have used the same function over here. Now let's just put it to our test. First of all, let's just add all these values which we already have. So the tree has the values 30, 40, 45, 50 and 60, where 50 is the root node. Now let's say if I want to delete 40, diagram over here. So this is our binary tree which we are using in our example. Now let's say if I want to delete the node 40 over here, this basically has two child nodes. So that is why we have created the minimum function over here, which is basically checking the minimum value, replacing it with the current, and then we are deleting that particular value from its position. Now if let's say if I want to delete 40, and we'll comment out this one, we can see the values are not here. So we have deleted the node 40 from our tree, and let's see if I wanted to delete 30, which is the last node, so we can easily do that. And if we let's say wanted to delete 45, we'll be able to do that. And if we want to delete 60, we're able to do that. So this is how easily we can delete the values from our binary trees. Now after this, the deletion, let's just take a look at how we can search for a value. Let's say if I wanted to search, alright, so we'll comment out this one also. So let's say if I wanted to search if 30 is present in the binary tree or not, it's returning true because it's already there. Now let's say if I wanted to check if 55 is present or not, so it's going to return false because it is not present inside the binary tree. These are all the functions and the operations that I wanted to show you in binary tree, guys. If you want us to do more operations on binary trees, and with this we have basically completed the binary trees, and now we are going to move to binary search trees, or a simple Python library that we have which can help us create binary trees and binary search trees. So the name of the library is binary tree, and from the binary tree module, what we are going to do is we are going to use the node, the tree, and BST and build module. Now, line by line, we'll just take a look at these. So first of all, we are going to use the node over here, which is going to basically create the root node for us, this particular statement. And after that, we can point towards left or right using the pointers over here and create a basic binary tree for us. So this is exactly how we had created the earlier binary tree. The root node is 50, and then we have on the right subtree we have 60, there is 40 on the left subtree, and again we have 30 and 45 in the child nodes of 40. Now this is how easily we can create binary tree using simple implementation from Python binary tree module over here. And after this, we have a simple implementation of, let's say, if we want to use a list to create a binary tree. What I have done over here is nodes is basically my list over here. 50 is going to be the root node, and subsequently all these values. So I'm using the build method over here, which is taking the parameter nodes as the input parameter, and it's providing us with the binary tree in the form of as you can see over here. So we have the root node as 50, then again we have 40 and 60 as child nodes, 30 and 45 as the child nodes of 40. So this is how easily I can create a binary tree using Python with a simple implementation using this binary tree package. After this simple implementation, let's take a look at how we can create a random binary trees. So there we have this tree method over here where we can decide the height of the binary tree as well. So for this example, I'm taking 3 as the height, and this basically is giving me a random binary tree with height 4, and then again we can decide on height using just the parameter. So these are random binary trees, and let's just stick to the height 2, and this is what we get for height 2 as a binary tree. Now after this, we can also create a binary search tree using the BST module over here, where we will get a random binary search tree. And let's see if we have any height parameters over here. So we can create a random binary search tree using just the height parameter and this particular module. Also, let's just check if we can give the nodes as the parameter over here to create this binary search tree. So this will not take the multiple parameters that we are providing. Just to let you know how many other operations you can perform on this, let's say this is our root node. Now let's just check what all functions are available to us. So we can check the height, we can check the in order traversal, we can get the balanced tree, we can get the BST binary search tree, complete the heap, the minimum heap, if it is perfect or not. We can check all these values. We can get the level order, we can get the post order. So let's just say if I want to get the post order of the root, so the post order is 30, 45, 40, 60 and 50, just like what we had got earlier in the examples. Similarly, if we check on the binary tree again, the functions, same functions will be available to us. And this is how easy Python makes your journey with all the data structures, the algorithms, all the classes, objects, function implementations, whatever you need. Python has made it simple for you guys in a very simple, easy to learn Python programming language, and the syntax is pretty easy to learn, and quickly you can grab hold of all the syntactical, the practices that you have to perform with each logic. Basically the logic is going to remain same for all the data structures what you have learned so far. Even if you have learned it in Java, even if you have learned it in C++, the logic will always remain the same. How you implement stacks and queues, how you implement binary trees, how you implement an array, how you implement linked list, the logic is always going to be same. Only the implementation will be different. With Python programming language, the implementation becomes a little bit easier with the inbuilt modules, and you can say you have different libraries for different functions. And then again, for using pure Python programming, you can implement the same as always. So with this, we have come to the end of the session, and just to quickly summarize what we have learned so far. So we have learned how we can create a binary tree and how we can insert and delete nodes inside a binary tree. We have learned about how we can search for nodes inside a binary tree, and we have used the implementation of binary tree using the module binary tree that we have from Python programming language. And now that we are done with this session, stay tuned for the upcoming data structure sessions for more such concepts. And if you have any questions, mention them in the comment section below, and we'll help you in your journey towards mastering Python programming and Python data structure. Thank you and have a nice day, and stay tuned for next part of this Python data structure series, in which we are going to talk about searching and sorting algorithms and graphs data structure. See you guys. Thanks a lot.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by E&ICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job.
Now that we are done with the session, don't forget to subscribe and press the bell icon to get the latest updates on Intellipaat.